Okay, this is video 1.3, unit 1, video 3. And you should be watching this Monday, 9/12. You will have a quiz on it tomorrow. Okay, so we're doing today, all right, so a limit, the final, utmost, or furthest boundary. We're going to be finding more limits. Yesterday's video was about left-hand limits or limits from the left. Today's is about right-hand limits or limits from the right. So I'm going to go a little bit faster than I did yesterday because it's really the same exact thing except you're coming from the right. Now, if at any point you feel like you've got this and you want to go ahead of me, then just pause the video, go ahead of me, but make sure to like fast forward or, make sure that we have the same stuff. Okay, you don't want to go ahead of me and then have it not be correct. That would be counterproductive. Directions. Given the following functions, use a table of values to determine the right-hand limit. So the first one, the limit as x approaches 6 from the right. From the left, there'd be a little negative superscript, but from the right, there is a plus sign as the superscript. The function is x minus 7 to the third. Okay, so just like the last video, if it helps you to draw a number line, to visualize what types of numbers are to the right of 6, then you can. Okay, so we're approaching 6 from the right. So a number to the right of 6 is 6.1. I want to get closer, so I'll add some zeros in front of the ones. And so my table of values will be 6.1, 6.01, 6.001. And then just like yesterday, I'm going to my calculator. I cleared mine. You don't have to. And I'm going to go to y equals. I'm going to graph the function that I'm finding the limit of as x approaches 6 from the right. And I go x minus 7 to the third. All right. I make sure that my table is set to ask for the independent variable because I want to be choosing what x values I'm finding the outputs for. And then I go to table, and then I'm going to type in these numbers, 6.1, 6.01, 6.001. I'm going to record them and then use an arrow diagram to analyze my table, and then I will get my answer. So I've got negative 7.29, negative, I messed that up. That's 0.7, sorry guys, that's not there. 0.9703, negative 0.997. Okay, so as the x values are approaching 6 from the right, is there a number that my y values are getting closer and closer to but never passing? And the answer is yes, and that number is negative 1. Okay, so that means that the limit as x approaches 6 from the right of x minus 7 to the third, that limit is negative 1. All right, guys, moving on. The limit as x approaches negative 7 from the right of x squared over x plus 7. All right, so I'm going to draw a little number line just so I can visualize the numbers to the right of negative 7. Negative 6.9 is 1. Negative 6.9, negative 6.99, even better, or even closer, negative 6.999. Back to my calculator. X squared divided by x plus 7 in parentheses. Whoopsie, I don't want that to the third. Hopefully that is okay. And then I go to my table. It's already set to ask for the input, so I'm just going to type those in. I've got negative 6.9, negative 6.99, negative 6.999. I'm going to record these numbers. I've got 476.1. I've got 4,886. So I already jumped pretty high. and then 48,986. Guys, if there were in fact a limit, I would not have these big jumps. Okay, the more nines I'm adding over here, so the more closer I'm getting to -7 from the right, the bigger these jumps are going to be. So there is no limit. The limit does not exist. So as x approaches -7 from the right, y approaches no finite number. We're going to say it approaches infinity, because it doesn't stop getting bigger and bigger. So the limit over here, it does not exist. Now, some people would write here DNE for does not exist. I'm going to be a little more specific than that and write infinity. Okay, now on to a piecewise function. We've got x approaching -1 from the right of g of x. Okay, so I'm approaching -1 from the right. So my x values the x values that I'm plugging into my table are going to be greater than -1. So the part of this piecewise graph that has x is greater than -1 is this part here. Okay, so that's going to be the function that I'm looking at. So a number very close to -1 but to the right is -0.9. Now I'll get closer, -0.99, -0.999. Now my calculator, y equals, clear that, x squared, go to my table, -0.9, -0.99, -0.999. All right, now I'll record those. 0.81. 0.9801, 0.998. So as x approaches -1 from the right, is there a y value that I'm getting closer and closer to but never passing? The answer is yes, and it is 1. So the limit as x approaches -1 from the right of g of x, this piecewise function, is +1. Okay, we're making good time. I'm going to move to the other page. This is, we're going to do it graphically. Guys, like I said before, we've already done this coming from the left side. Today is just like the last lesson, except I'm coming from the right side. So if you feel like you can do this faster than me and you don't need me guiding you through it, you can pause this, go ahead of me, but then make sure you fast forward through the video to make sure that we're agreeing on our answers. Okay, so here I go. The limit as x approaches 1 from the right of f of x, whose graph is here. So I'm approaching, my x values are approaching 1 from the right. And so I could have 1.1, 1.01, 1.001. All right. And then the y values I'm going to be estimating. All right, so for 1.1, for example, it's like right over here. And so in 1.01, 1.001, same. So there, the part of the graph that corresponds to those x values is right here. It's like right above that open circle, which means that the function is undefined there, by the way. There's a hole in the function at the open circle. And the y values that correspond to this part of the graph are the y values that are just right up above -1. Okay, and the closer I get to that open circle, the closer my y values are getting to -1, but they're still going to be right above it. So 1.1, the y value that corresponds to the x value 1.1 is going to be pretty close to that open circle. So its y value is going to be pretty close to -1, but above it. So -0.9, for example. 1.01, that x value will have a corresponding y value even closer to -1, but still above it. So -0.99, for example, and then even closer for the last one. I am just estimating here, guys. I don't know what those actual y values are, okay, because I don't know the equation of this function. So, although it is a parabola. So as x approaches 1 from the right, my y's are approaching -1. All right? So the limit as x approaches 1 from the right of f of x equals -1. Alrighty. Now this next one, x is approaching -2 from the right. Just like our example yesterday that was kind of like this, there is a vertical asymptote at x equals -2. I'm approaching -2 from the right. So on this side of the asymptote, the function's graph is going down, okay? So to the right of -2 would be -1.9, -1.99, -1.999. Now -1.9 is so close to -2 that really we wouldn't be able to see it with our eyes, its exact point on this paper here. So its y value, this is a very steep part of the graph. Its y value is going to be so low that we wouldn't even see it on this graph. So I'm going to estimate, just like I did yesterday for a similar example, -100. This part of the graph is extremely steep. It gets steeper the closer we get to that asymptote. So I'll go up by a factor of 10. So -1,000. I'll go up another factor of 10, -10,000. Those are estimates, guys. I have no idea what those y values really are, but I know that they're getting bigger and bigger. Okay, so as x approaches -2 from the right, y is approaching no specific number. It's just getting lower and lower and lower, and its jumps that are making it go lower are getting bigger and bigger. So -infinity. So that's the limit up here. Whoops. There we go. Okay, here's some more. So x is approaching -4 from the right. All right, so here's -4. To make this easier on me, I'm going to go up to the graph and put a point on the graph that has the x-coordinate -4, and I'm just going to estimate its y-coordinate. I'll say -4, comma, what does that look like? 3.5, maybe 3.6, 3.5 I'll choose. Okay, so x, we're approaching -4 from the right. Okay, -3.9, -3.99, -3.999. And notice as my x values get closer to -4, the part on the graph that corresponds to those x values is getting closer and closer to that point. And if I get closer and closer to that point, my y values are getting closer and closer to the y-coordinate of that point, which is 3.5. So at -3.9, my y value is going to be pretty close to 3.5. So I'll say 3.49. It's pretty close. And it's just going to get closer for these other ones. So I'll say 3.499, 3.4999. So as x approaches -4 from the right, the y's are getting closer and closer to the value 3.5, but we will never pass that value. So the limit here is 3.5. One more. Okay, this is a piecewise, the graph of a piecewise function. X is approaching -1 from the right. So I look at my graph, I'm approaching -1, I'm on the right side of -1, a number very close, -0.9, closer, -0.99. Okay, so the part of this graph that corresponds to the x values to the right of -1 is this part, which looks like it's part of a parabola. So I'm very close to -1 as an x value. That would put my y value somewhere down here below the end point of this part of a parabola. So the y value is going to be just a teensy bit lower than -2. So for example, -2.1. And the closer my x value gets to -1, the closer my y value will get to -2, but it's still going to stay below it. So -2.01, and then even closer. So as The x's approach -1 from the right. The y values are approaching -2. So the limit as x approaches -1 from the right of this function f of x equals -2. Okay, now, so that's that, guys. For homework tonight, you are going to have, let me look in the packet. So for homework, you're going to have pages 7 and 8, all of them. Okay, so all of pages 7 and 8. And just be very aware, some of these are limits from the right or right-hand limits. Some of them are limits from the left or left-hand limits. So you have to pay attention of whether there's a little minus or a plus as the superscript. That'll tell you if you're going from the right or the left. And then on page 9, let's have you guys do just number 8. Okay, so one factoring problem. So on page 9, please do number 8. So let me repeat that. The homework for tonight is pages 7 and 8 to all, and page 9, number 8 only. Okay, see you tomorrow.